Okay, so when you think about the two types of radiation-based solar particle events, you do have the risk of acute effects. So these would be nausea, vomiting, even mortality if you were totally unexposed over the whole length of a large event, large solar particle event. This would be less than 5% of all the events we know about would have sufficient dose to cause that. So we definitely want to be prepared with radiation shielding and alert systems that get behind the radiation shielding. Now there would also be a residual risk for cancer, and this would be actually the major concern for solar particle events would be the lifetime cancer risk that would occur and other late effects that are commonly related to aging, like cataracts, heart disease, and some other diseases of aging would be increased by a solar proton event. Now, fortunately, most solar protons events are relatively small doses, about almost 95% of them are relatively small. So the real concern for NASA is the operational disruption that will occur for these 95%, because the problem is we don't know when the event will be small or large until well after it started. So even though 95% are small, we don't know that until about 4 hours into an event that it's going to be a small one. So there'll be a lot of mission disruption. The other major component is the galactic cosmic rays. These ones are the ones we can't shield against, and there's less known about the biological effects. So we're not concerned at all about acute effects from galactic cosmic rays, but we're concerned about cancer risk, cataracts, heart disease. And there's also some concern about damage to the central nervous system. This would be either short-term or long-term cognitive changes and loss of motor skills, and perhaps even CNS effects of the old age. Alzheimer's disease, for example, would be a concern.